Hi, in this video I'm going to show you 6 vulnerabilities I found in the identification system in Sweden 6 years ago, which gave me access to 11 banks and several organizations such as Swedish tax agency and insurance agency. The last one was published by a Swedish magazine called Ny Teknik. I put the link in the description in case you are interested and you want to read it. First of all, the reason I'm making this video in English is because the same system is being used in several countries such as Norway, Finland, and I don't know how many more. So I hope you enjoy and find this useful for your projects. But before I start, let me say that all the content in this video is only for educational purposes, so please don't use it to hack anyone or do anything illegal. Otherwise, you will be responsible yourself. I don't take any responsibility. I will start by showing you the evolution of online banking, which goes back several decades. So if you already know how online banking evolved in the past 3 decades and you know exactly how bank ID works, then you can just skip this part. I will try to put the timeline in the description in case you want to skip to the right time. When I first opened my bank account many years ago, the only thing we needed to log into our account was a username and a password. And in this case, the username was our social security number, which in Sweden we call personnummer. But as you might know, using username and password is not secure, especially when you're doing financial things. And the reason is because your computer could be hacked at any time, and the hackers can just steal your password with a simple keylogger. So keylogger is a program that can capture every button you click on your keyboard. So banks came up with an idea to give users one-time PIN codes. It means you received a list of 100 PIN codes from your bank, and each PIN code could be used only once. When you wanted to log in or transfer money to anyone, then you had to use one PIN code. It wasn't a bad idea, but there was 2 problems. The first problem was that when you ran out of codes, then they had to send you another list with 100 more PIN codes, which wasn't actually cost effective for them. The second problem was that you had 100 PIN codes, and each PIN code was 4 digits, which gave hackers 1% chance of guessing the right code. So they could just brute force. If you're a programmer, if you're a hacker, then you know what brute force means. So they could brute force your code and find a new one every time. The only thing banks could do to prevent this brute force attack was to just block you out from your account every time you entered a wrong PIN code, just for a minute or so. So in 1 minute you couldn't try again to enter your account. But that was also a problem because anyone who knew your social security number could just block you out from your own account by just simply using a JavaScript code to just send wrong PIN codes with your own personal number just to block you out from your bank account. The next solution to these problems was to create a digital token, what we call DUSA in Sweden, and it doesn't even require internet connection, and it is still being used in Sweden and many other countries. It works like this. When you open your bank account, you receive a token from your bank which looks like a calculator, and inside of that token there is a long string which is unique for each user. So let's say your string is something like this, 1786 blah blah, and this is not like anyone else's string. Now I'm not going to go into details exactly how it works, but let's just say your string is stored in 2 places. The first place is in your token and the other place is in the bank's database. So each time you want to log into your account or transfer money or do anything, you need to generate a hash using that token, which uses that string. Then the bank checks if the hash is the same as the one they can generate in their system, and if they're the same, then you can log into your account. I cannot say that solution is flawless, but it works fine, and by now this is the best solution we have. And the reason is because there is no internet connection, so there is no connection between the token and your bank. So there is no way for a hacker to connect to your token and steal that string. About 10 or 12 years ago, when I was working in a company in Stockholm, I heard about a new authentication system in Sweden called Bank ID, which was getting very popular back then. When I heard about it the first time, I thought this is the worst idea because it's like going back to the same username and password, which is not secure. And I mean, if my phone gets hacked, then I lose everything. Some people think Bank ID is some kind of two-factor authentication, but it's not, because with two-factor authentication, something like Google Authenticator or something, first you have to use your username and password to log in, and when they know that you might be you, then you can use Google Authenticator to tell them again that you actually are you. But in this case, with Bank ID, you don't do that twice. You just do it once because it's very easy to get someone's national insurance number. And the only thing you do, you just put it on the website and then you open the app and you can sign. So this is not a two-factor authentication. This is just one-time authentication, actually. When I heard about Bank ID the first time, it was getting more and more users every day, and almost every bank and organization was working with them. So I thought, okay, whatever, I have other things to think about. I don't have time for this. But then, November 2015, I was working on a payment system for my own startup company, and it required lots of testing and signing with Bank ID. And I think it was 2 o'clock at night. I thought, wait a minute, buttons blink when I enter my PIN code with Bank ID. The first thing I thought about was, do they have Flag Secure in their app? And they didn't. Actually, when I checked that, they didn't have Flag Secure. So let me explain what Flag Secure is. If you have an iPhone or an Android, then you know how Task Manager works. There's a button in all smartphones. You can just click or double click, and you can just see a list of all programs in the background, and you can just close them by swiping up and down or left and right. When you open Task Manager, you see the content of each program. So you can see what's inside of those programs before you change the program. But some programs are blank. You can see them. You can see the content inside those apps. That means that application has Flag Secure turned on. If you're a developer and you develop applications, then you know it's just one line of code to activate Flag Secure. So how could this be a problem? If you have ever used an application to remote control your phone, just something like TeamViewer or mirroring your screen on another device, then you know how it works. You can just remotely access your phone. The same thing for your computer. You can just remotely control them. You can do anything. You can just type. You can click. When I found this vulnerability, most people were using Android Jelly Bean or Android KitKat. That's the version of the Android, the latest Android that time. So any application with the same permission as TeamViewer could just easily see your home screen. They could even see your lock screen. They could see all the PIN codes you enter, and even the PIN code you enter in your Bank ID. And the main reason they could see your Bank ID PIN code was because the buttons blink. But when an application has Flag Secure turned on, then no one can see the screen anymore. They can still see my home screen, but as soon as I open my, let's say, Bank ID, which has Flag Secure, then the screen will be white. They can't see the content. They can't see the PIN code I'm entering. So let me explain how an app could hack my Bank ID. But before that, as you know, there are lots of sensors in every smartphone. We are going to need 2 of them for this hack. The first one is the accelerometer, which can show in which position my phone is, and the next one is the front camera. Let's say I have a game app on my phone which has access to my screen. It can capture my screen just like TeamViewer, and it has access to my camera, and it can see my accelerometer. The first time I open the game, it looks normal. It doesn't look anything weird. But behind the scene, it's recording my screen. It can see everything I do. And at first, it doesn't do anything. It just waits for me to close the app. And when I close the app, it continues to record my screen. And as soon as I open Bank ID, let's say it's today or tomorrow or whenever, I open Bank ID to do some financial things, and it can see the PIN code I enter, and it can even see my national insurance number when I enter it in Nordea's website or any other bank. Now it has my national insurance number and it has my PIN code, but it waits. It doesn't do anything weird yet, because the app needs to know if you're using the app or not, because if anything happens to your phone while you're using it, then you are going to know that something is not right. So it just waits and checks your accelerometer, because when you have your phone in your hand, then it's moving. So it can detect that you're moving and the accelerometer is active now. So it waits for the accelerometer to stop changing. And when it stops changing, then now it needs to start the front camera to see if anyone is actually in front of the camera or not. And when it's not, then it's the good time to start the attack. So now you put your phone on the table and leave. And the app can detect that accelerometer is not changing anymore. It starts the camera and sees that no one is in front of the camera. So it's a good time to attack. It just goes to a website. Let's say it goes to Nordea or Swedbank or any other bank that you have, puts in your personal number, your national insurance number, and then it opens up your bank ID and signs. Here's where when you lose money. But the problem with this hack is that because everything is happening in your phone, then you have no chance of proving to the authorities that you have been hacked, because everything has happened on your phone and with your own IP address. So I'm not going to talk about what happened when I first found this vulnerability and when I had meeting with authorities. Let's leave that for another video maybe. But let's just say when I had meeting with them, it took them over 2 months to release an update for Android just for one line of code. And usually when companies or organizations find some vulnerabilities like this, they usually tell people about that. They say, okay, we found this problem and we have fixed it. But in this case, they didn't do anything. They didn't say anything. And the only thing they wrote in the description of their update, it was improvements. So no one knew why they updated the app. So let's go to the next vulnerability. But before we start, you need to know 2 permissions. It's mostly used in Android. It doesn't work on iPhone as good as it works on Android. So some of you might say, okay, this one is an operating system based problem. But actually, while it's true, I disagree with that, because it could be prevented. So Bank ID could prevent this one, but they didn't. The first permission I want to talk about is something called install shortcut. So any application that have this permission, they can just install any shortcut they want on your home screen. So let me just say that there's a huge difference between the new version of Android and what was being used at that time, 2015, because most people were using Android KitKat or Jelly Bean, and there was lots of differences for creating shortcuts on this home screen. So it seems like Android found out about this problem and they just updated that. We start by seeing how this permission works. If you have an Android phone, just open up Google Chrome, go to a website, it doesn't matter what website. Then at the top right corner, click on the settings and click on add to home screen. And what happens here is that a pop-up will open up. It will show you the fav icon of that website. If you don't know what fav icon is, it's just unique for each website. They can have any type of icon they want. And then it asks for a name, which is provided by the app, which in this case is Google Chrome. When you click on OK, a shortcut will be installed on your home screen with that icon and the name that you provided in the pop-up. But the thing now is that when you see the icon on your home screen, you can see the icon, but you can also see the icon of the original app, which is Google Chrome. So you can see that a very small icon at the bottom right corner. So these are two major differences between the new Android and the old ones. Because in the old ones, you didn't need to ask the user. You could just install any icon without even the user knowing that. You could just install by code without even showing any pop-up or any confirmation. And the next major change was that you could just show your own icon, any icon you want. And your own app icon was not visible. It means you could just fake any app you wanted. I could just install a shortcut on the home screen which looks exactly like, let's say, Bank ID or Nordea or Swedbank or anything. What you need to know here is that when you click on that icon, it's going to open Google Chrome. And in that case, if you install a shortcut on the home screen with your own app, when the user clicks on that app, on that shortcut, then it will open up your application, not Bank ID, not any other application. But if you're a developer, then you need to know that you need three things to install a shortcut on the home screen. The first one is the icon. The next one is name of that icon. Let's say we say Bank ID. And the third thing you need is a payload, which is a variable. And each time a user clicks on that icon, that variable is sent to the application. It doesn't matter which application it is, it's going to receive that payload. So in this case, you can see exactly how your application was launched. So if the user clicks on your own application icon, which was installed when they installed your app, then they will go to the app without sending any kind of payload or any kind of variable to your application. So you know that your own icon has been clicked. But when you install a shortcut on the home screen and you put some kind of payload, some kind of variable inside that, then you know exactly when the user has clicked on that fake shortcut. It means you can just change the behavior of your application according to which icon they have clicked on. So if they click on the original icon, then you just open up your application, which could be a game or something. But when they click on the install shortcut, you can change the behavior. You can even change the UI. You can change the design, which could match Bank ID or any other application. So if you're a developer, I'm guessing you already know where I'm going with this. I'm guessing you already know what the problem is. But there's one more permission we need for this to happen. So the next permission you need to know about is something called draw over other apps. But first, let me say that there's been some major changes with the new Android in this permission. So it doesn't work the way it did back in 2015, but it still works, but not that way. So it's a major problem with security with this permission, which means every application that has this permission, they can just draw anything. They can change everything you see on the screen. So let's say I open one application and I'm seeing a text. So if any other application has access to this permission, they can just change the way I see that application. They can just draw something on top of that application. So what I'm seeing on the screen is fake. It's not real. So an application that has access to this permission, they could just change what text I'm seeing inside of Bank ID. So when I open up my Bank ID to sign, I'm seeing that it says I'm logging into my bank account, but behind the scene, actually what is happening is that someone is transferring money from my account. So what I'm seeing on the screen is fake. It's not real. So I'm guessing you already know where I'm going with this. You know exactly how the hack works, but I'm going to go through the hacking process anyways. Now, how could this be a problem? How can someone hack my phone, hack my bank ID using this method? Let's say I install an application on my phone. It's a game. So when I open it up, it looks normal. It looks just like a game. Nothing suspicious. But behind the scene, the first thing it does, it installs a shortcut on my home screen, which looks like Bank ID, which is not, it's fake. Now I have two shortcuts on my phone which go to the same application, to the same game, with one major difference. The first one is the application's icon itself, which when I click, it just goes to the application. It's a game, nothing suspicious. But the next one, which was installed by the application itself, it has a payload inside. So when I click that one, it looks exactly like the Bank ID's icon. So when I click that, a payload is going to be sent to the application. So it knows that I clicked on that shortcut, not the real shortcut. So when I do that, the application can change its design and look exactly like Bank ID. So I suspect nothing, and I'm going to enter my PIN code. I enter my PIN code and it steals it. So now the hacker has my PIN code. But this is not what the hacker wants. They're after your money. They don't want your PIN code. Of course, having your PIN code is also good, but this is not what they want. They want your money. So let's say instead of creating a shortcut which looks like Bank ID, they just create another shortcut which looks like, let's say, your bank. In this case, let's say it looks like Nordia's icon or Swedbank's icon. And when I click on that, then the application knows that I have clicked on that icon, and it will change its design to look just like Swedbank's app or Nordia's app. So it waits for me to enter my social security number. I do that and I click on login. And when I do that, instead of logging me in, it just sends my social security number to the server, to its own server, not Swedbank server. It sends to its server, and from there, it's going to try to log into my account. But it needs me to sign in with Bank ID. So how does this happen? So first, my social security number is going to be sent to the server. It tries to log in, and then the application is going to open up my Bank ID. But of course, I'm going to see that message on the screen which says you are now going to log into Swedbank, which I already know. So I know that I'm going to log into Swedbank. But the problem is that I'm not going to log in for myself. I'm logging for the hacker. And when I enter my PIN code, by the way, this is the real Bank ID we have opened. So this is not the fake one. I enter my PIN code, I sign in, and instead of signing in myself, I'm going to sign the hacker in. But here, there are many different ideas the hacker could have. The first one is just to wait for you to make a transaction and fake that transaction. But an idea that I have was that instead of just logging you in, you can just say, sorry, it didn't work and you have to log in again. There was some problem with the server. And you will try again, why not? So you click on the login button again, but this time it's going to send the information to the server and say, yeah, he wants to log in again, but we are already logged in. So let's go and make some transactions. On the server, it goes and makes some transactions and waits for you to sign again. And it opens up the real Bank ID for you to sign. But this time you are going to see the text on the screen. You will see that some money is going to be transferred. But here's where the next permission comes in. Draw over other apps. So the application knows that you are going to sign, and it knows that you are going to see the text. So it covers that text with a normal text and says, hey, you are going to log in again. So there's nothing to be suspicious about. You sign in again, but this time you are going to transfer money to the hacker. Again, let me say that I'm talking about 2015. Everything has been changed now, and thanks to Android and iOS, they have changed many things and it's more secure. But back then, you could do any of this easily. You could just hack anyone. And as I mentioned before, just to make it easier to understand, I said that the application is going to send the information to the server, and the server is going to try to log in. But actually, it doesn't even need a server. So if the hacker puts some more time on that, they can just do it in your phone instead. So if you're a programmer, then you know what a web view is. So they can just open up hidden web view on the app, which you cannot see. They can just do everything they want inside the web view. They can go to your bank account, they can log in, and they can just simply inject a JavaScript inside of that web view. That's very easy to do. And in this case, they don't even need a server. And the good thing is about this is that when they do it inside a web view, then everything is going to happen inside your phone. So even if you go to the authorities and just claim that someone has hacked you, when they take a look inside the server, they see that every request has come from your own IP address. So there is nothing indicating that you have been hacked. As I mentioned before, there are 6 vulnerabilities which I have found. 5 of them I found 2015, and the last one, the 6th one, I found like 8 months ago, which was published by the Swedish magazine called Ny Teknik. So I thought maybe I can give you all of them. I can explain exactly all 6 of them, but the video is going to be too long. So let me just have that in the next video. And if you're interested, if you like this video, if you enjoyed it and you find it useful, then please subscribe to this channel and please like my video for others to see it. And I will try to make the next video as soon as I can. And by the way, if you like to see these hacks in action, then let me know down in the comment section. For obvious reasons, I won't hack anyone, but I can do it to my own bank account, so you see how it works. One more thing I need to add is that these 2 hacks that I mentioned only work on Android, but the next ones work on iPhone and other operating systems. I will show you later. Thank you for watching. Don't forget to subscribe and hit the notification button, and I will upload the next video as soon as I can. Thank you.